Michael sent me this with a curiosity of, I don't understand what they're getting at with this, which was a fantastic question, because what they're actually getting at is a little bit misguided. So, participants were 31 women, pretty small sample, but that often happens, especially if you're measuring things versus counting things. 16 African American, 15 white, of similar age and similar BMI. I'm assuming that's what similar BMI means. Now, if you take out the mathematics in that and just read the sentence, I think we can understand what they're getting at. We had 31 women who were all aged similarly and they were all BMI'd similarly, okay? But now, what they did was they broke it down into 2 intervals. I'm assuming now, I'm assuming this is the 16 African American and the 15 white, this interval, that interval, and then again here, the 16 and the 15. So what they're doing is they're looking at the races and trying to decide if there is a difference in age and or BMI between the 2 races of women in the study. Everybody fair with that? So in other words, try to control for a variable. We've mentioned this before, that sometimes variables sneak in a study. Suppose this study is measuring metabolic rate. Suppose. Well, you want to control for every variable you possibly could, so 2 of those are age and BMI. For example, age, as you age, your metabolism on average slows down. So you might want to control for that in the study. And I got no issue with that. None at all. The problem I have is how they reported the results. So here is the confidence interval on the ages, I'm assuming, of the 16 African American women, and that's the confidence interval on the ages of the 15 white women in the study. Notice the average age was 37, the average age was 38, that's pretty close. And then you put the standard deviation on there, what is it, 9 years and 11 years. And those intervals completely overlap each other, yes? And I got no problem with that. The problem I have is this. They put a p-value on it. Now you remember, there's 2 relative sizes of p-values. What's the cutoff number that's sort of magical to us that we use for comparative purposes? 0.05, 5%. When you see a p-value that's 5% or less, what's the first indication? What's the indication? Something's unusual. Okay, something's unusual. What would be unusual in this study if we were looking at the ages of the African American and the white women? If they were different from each other. The idea is, are they the same or are they different? Well, you go in there assuming they're the same and try to prove that they're different. This fails to prove they're different. It's too big. It's too big a p-value. It's huge. It's 72%. It's far too large. If you imagine the curves, they lay on top of each other essentially. There's no 2 separate curves. But that's the problem with it. We shouldn't be talking about curves. The only time you have to use a p-value is when you take a sample and do what with it? What's the point of drawing a sample? To apply to a population. Now, I'm not saying this study isn't going to apply to a population, but it's not comparing the ages of African American and white women in the population. It's comparing something else. They were controlling for the variable in the beginning of the study. So everything, Michael, except for that, I'm solid with. I just don't think you should put a p-value on it, because by putting a p-value, they're trying to make an inferential statement about all African American and white women, and they have the same age. Which obviously is untrue, yes?
Plus then only you understand it.
Say that again?
Plus then none of us understand.
Well, that's true! I mean, but do you remember when I told you guys last week that the first time I ever Googled what is a p-value, it came back with the wrong result online? I think I told you that in the last class. Your next exam question, your first exam question on your last exam will be, go to this link, Google what is a p-value, find the first hit, and tell me why it's wrong. It's one of the most misunderstood things in all of statistics. One of the most misunderstood things. Like right there, using it right there. You shouldn't be using that right there. If you think their ages are the same in the sample, then just draw the results of the sample. And look, oh, in the sample, these 16 and these 15, they're essentially the same. There's no reason to give a p-value to it, because that just implies that there's a population out there you're looking at with respect to age or BMI. See the BMI, 0.21? Also above, what magical number? Also above 5%, yes, also above 5%, which means nothing significantly different, nothing unusual. So everything's cool in this, Michael, except for the p-values. And I love what you just said. Plus, it confuses you. It should confuse you. It shouldn't be there. That was why I wanted to talk about it in class. Because you guys will see this time and time again as you consume your journals. And that's what Jamie was saying. Thank God. Thank God. Because I have to read these all the time. And I don't think a lot of healthcare practitioners really understand what they're reading. He does. And that's why he's saying, thank God you guys are sitting here right now. So I love the fact that we're going to crunch numbers. I love that too. But more importantly, I love the fact that you're starting to understand why this does or doesn't make sense. That's way more important, honestly. I mean, one or two of us in this class is going to go on to do research statistics all the time. But every single one of us has to understand the news and what's in the news, whether we should believe it or not. So that's kind of what today is. It's a fusion of both. We'll be doing the tests without collecting the data, so I just hand you all that. You're welcome, by the way, the data sheet. But the idea is that you have this data sheet, you've got the data, let's crunch the numbers now. And thank you, Michael, for this. That was fantastic. So it's one of those things that looks official, looks legit. And most of it is, except for the damn p-values, which are extraneous. So, thank you. Thank you. Sometimes you should make things inferential.